My voice? Can you hear my voice? Okay. In the last session, we talked about data visualization, and we talk about different type of graphs and charts, which are useful for representation, for data representation. And in the last of uh, that session, we talked about similarity measure, and we shows how we can uh, calculate similarity between two different nominal objects. Also, we talk about Jacquard similarity and dissimilarity too. Today, we want to continue uh, those statistics and those metrics. Firstly, we start with Z-score. Z-score is one of the is another measure to calculate the difference between two objects. For example, if I have object X, if I have is there any problem with my voice? Can you hear my voice correctly? Okay. Z-score is calculated in this way. If I have object X in a data set with mean of mu and a standard deviation of sigma, then its z-score of X is calculated in this way: X minus mu divided by sigma. This formula shows the distance between X and the rest of population in dataset. Here we have a standard deviation which a standard deviation calculation is not simple. It's a little difficult. So sometimes some people use absolute deviation instead of a standard deviation. Absolute deviation is calculated in this way, which is much simpler than calculation of standard deviation. As you can see here, it just calculate the distance between one item and between one item, one feature, item in one feature with mean value of uh, data at that feature, mean value for all features, for all data at uh, standing for that attribute in dataset. Okay, we just simply calculate the absolute value of these differences, and finally divide after summation of all these differences. Just simply we divide them by n. This calculation is very simple, and sometimes some people say that using absolute deviation is more robust than using a standard deviation to calculate z score. It's an opinion, and maybe someone accept this opinion, maybe someone does not. Okay. Uh, Sometimes all data are completely numerical. When all data are numerical, we can think and we can present those data in a matrix. For example, in a 2D or 3D space. Then, if I have something like this, a data matrix of numerical data, then I can decide about distances and dissimilarity or similarity upon or based on simple algebraic distances like Euclidean distances. For example, here we have four different data objects: x1, x2, x3, x4 here in this data matrix and in this 2D space. Then I can define the distance between these points using Euclidean distance. We learn how to calculate Euclidean distance in higher school, in the school. Okay. But what is the basic of Euclidean distance? If we look for the root of Euclidean distance, we should talk about Minkowski distance. Here, in slide 56, the general formula of Minkowski distance is presented. In this formula, we can see a variable h, which is unknown. Here, variable h in Minkowski distance is unknown. We should talk about this. But before of this, we should talk about some properties of Minkowski distance. If distance between I and j is always positive. If also distance between I and j is equal to distance between j and I, and the third property is that distance between I and j is smaller than or equal to distance between I and k plus distance between k and j. This is triangle inequality. Okay. These three items are properties of Minkowski distance. But what is h? We have three choices for h. If h is equals to 1, we say Manhattan distance. Look at here, Manhattan distance. Simply, we should find the absolute differences for data in each attribute. And find the total distance, just sum these absolute values. This is Manhattan distance. It's something like Hamming distance. We call this Hamming distance as L1 norm for Minkowski distance. If H is 2 or L2 norm, we called it Euclidean distance. Which we know this formula. And if we put H as infimum, we call L infimum norm or supremum distance. Look at this formula in the bottom of slide 57. di of I and j is equal to limitation of this equation when h is going toward infimum. It's equal to maximum differences between values of one attribute. Here we are calculating the differences between values of different attributes. Which one, this among these differences, which one is the highest value? Which one is bigger than the other? This limitation is shows like this: maximum differences between values of one attribute. We have different differences. We will catch the maximum difference as the supremum distance between I and j. Let's give you an let's show this example. Let's see this example. Question. Sorry for interrupt. I had a phone call. Sorry for that. Okay, I have 4 points: x1, x2, x3, and x4. Each of these points has two attributes, attribute 1 and 2. And you can see here in the up left, you can see data matrix of these points. Okay, I'm deciding to calculate distance between two of these points. Okay, I'm starting. For example, I am deciding to calculate the distance between x1 and x2. Okay, if I'm looking for distance between x1 and x2 using Manhattan distance, I should calculate the differences between values in attribute 1 and between values in attribute 2 and present the sum of these values. So the distance is absolute value of 1 minus 3 plus absolute value of 2 minus 5. If I calculate this one is 2 and this one is 3, so the result is 5. The result is 5 here. Here, look at this. The result is 5. The distance, the Manhattan distance between at point x1 and point x2 is 5. What about Euclidean distance between them? Okay. To calculate the Euclidean distance, I should do something like this. 1 minus 3 power of 2 plus 2 minus 5 in power of 2, which is equal to 4 plus 9 square root of 13, which is equal to 3.61. 3.61 here and here. This is the Euclidean distance between x1 and x2. And I'm looking to calculate the supremium distance between x1 and x2. So I'm writing maximum value of 1 minus 3 or 2 minus 5. This is equal to 2 and this is 3. So the maximum value is 3. I can see the differences. If I'm using Manhattan distance, the distance between x1 and x2 is 5. If I'm using Euclidean distance, the distance is 3.61, and if I'm using supremium distance, the distance is 3. Okay, but as I'm looking here, I see that the Euclidean distance is Euclidean distance calculation is more difficult than the others. Manhattan distance is simple, supremum is simple, but Euclidean distance is hard to calculate. It's difficult to calculate. It's not hard, but it's difficult with respect to Manhattan and supremum. Is it enough, or I can calculate one bit distances between x3 and x4 if you want? Is it enough? Or I calculate another example. Please give me a feedback. Should I calculate distance between two more data points? Yes or no? Or it's enough? Can you hear my voice? Everybody in the class, can you hear my voice? Yes or no? Okay. Is this example was clear, or I should give another example? Calculate another option. Enough? Okay. Okay. When we are talking about nominal data, as we talked, for example, when we are talking about colors, I couldn't find a good measure to calculate the distance between, for example, white and black, because they are nominal. And I couldn't find a good measure to calculate the distance between white, black, green, blue, yellow, I don't know, rest of colors. But in nominals, when we are talking about ordinal variables, variables who have a rank, for example, military ranks. For example, military ranks. When we are talking about ordinal variables, variables that have a specific ranks, I can place those ranks in an ordered manner, like this, from 1 to m, in an ascending manner, putting all ranks in an ascending manner, 1 to m. This is a special case of nominal variables. Here, in these variables, ordinal variables, I can use rank of those variables instead of their nominal values. For example, in military ranks, we have soldiers, major, and generals. Simply, I can replace them with 1, 2, and 3, and something like this. Okay? Instead of saying, for example, a simple soldier, I can say 1, rank 1. For example, if I'm talking about a general, I can say rank, for example, 10. I don't know, something like that. Okay. This means that I can change ordinal variables into numerical variables. Still, these variables have their ranks. I should be clear about them. But now I can find their distances easily. For example, if I'm looking for distance between a simple soldier with a major, I can use, for example, Manhattan distance or something like that. And also I can find the distance between a simple soldier and a general. Calculating these ranks can be effectively and easily be done just with replacing the ranks instead of nominal attributes. In colors, I couldn't do something like this because there were no rank or there were no special metrics to, for using them. Okay, but there is a specific case here, not only for ordinal variables. This is for all type of numerical variables too. Uh, Suppose that I have a data set with two different attributes, one for age and one for salary. Okay, I know that the age is a number between for example 1 to 100, something like that. But when I'm talking about salary, it can be placed between 1,000 to, for example, to $20,000 per month. As I see, the range of ages is much smaller than the range of salary. Age is standing between 1 to 100, but salary is starting from 1,000. Their range is has their range has a wide difference. There's a wide difference between these ranges. Indeed, in such cases, in data mining, we are using normalization. What does it mean? Normalization means that I am changing an interval into interval 0 to 1, changing one range into the range between 0 and 1. How can I do that? Just simply using this equation. For example, I have a value of r, and the maximum value in those set is m. If my data is ordinal variable, I can use simply this, r minus 1 divided by m minus 1. M of f is the highest rank in ordinal variables, or the maximum value in a set. And r is a data object, is an example. When we are using similarity, when we are using normalization, then the range of attribute age is changed to 0 and 1, and also the range of attribute salary is changed into 0 and 1 too. Both of them, after normalization, both of them will change into the range of 0 and 1. And this is important and and this is a very good option. We talk about it later in this course. Okay, and we can find after changing ordinal variable into numerical value and maybe normalizing those attributes, we can simply find similarity or dissimilarity of those data. One more question is that what will happen if I have a mix of attributes, mixed type of attributes, different types of attributes? What will happen? Here, for example, I have a nominal attribute, I have a numerical attribute, I have binary attributes, I have ordinal attributes, and so on. Okay, I have a data set with different types of attributes, and I'm deciding to find the distance between those objects. Each object is a roof or is a record in my data set. I'm deciding to find their distances. What should I do? Firstly, we say that for each attribute, upon the type of that attribute, okay? Upon the type of that attribute, for each attribute, I should calculate the distance or similarity and dissimilarity of those attributes, those values. For each attribute, I should calculate the distance or the difference or dissimilarity between the values. Then, in the second step, I should define a variable weight for each attribute. It's very important. I should define a weight for each attribute. Why? Because when we are talking or when we are working with a data set, most of times all attributes have not a same weight in our calculations. For example, I'm thirsty. I should be stand in a queue to give some water, okay? But I see a child, a baby boy or a baby girl who is thirsty too. If I calculate simply, I will say, okay, stand in a queue after me. But when we are living in a society, I couldn't act like this. I should say that, okay, he or she is a baby, so he must serve first. He must give water first before me. Because he or she is a baby, or he or she is an old man or an old woman. It means that I'm giving a weight to that people. It means that his or her weight is not equal to the weight of other people for me. So I'm saying, okay, please serve him or her first. Okay. In dataset, we have a similar problem, and we couldn't assign a same weight to all attributes. Some attributes are more important and some attributes are not. Uh, Sometimes values of attributes uh, can affect the result. For example, uh, attribute age and attribute salary. As we see, the range of attribute age is much smaller and lower than the range of attribute salary. So if I decided to think about these two attributes together, I should give a very low, very small weight to salary and a large weight and a large weight to age to cover their difference in their interval, to cancel the effect of uh, higher number of salary with respect to the age. I have to do that. So I should put some weight to attributes, and then I can decide about the weight of those objects, data objects, using this calculation. Sigma of weights divide times in uh, distance of that attributes divided by summation of all weights. Okay. Uh, as I said, I can use normalization. If I use normalization, then I can ignore these weights. Normalization is another type of putting weight on different values. Maybe someone, after normalization, someone decided to still have some weights. It's a choice. I don't know. But normalization is a useful object, is a useful tool here to remove the weights. In most of cases, we can remove weights just using the normalization. But it's not a general case. Be careful. It's not a general case. Maybe in some cases you have to put normalization and weights together. Okay. Okay. One more way to calculate the similarity between two objects is Cosine similarity. When I'm talking about search engine, for example, Yahoo, Google, Bing, something like that, they are search engine. How they gives rank, how they give rank to different web pages. Or I have some books. I'm deciding to uh, write a search engine program for my bookstore, for example, or my library. How can I prepare a good searching mechanism in this case, for example, for book or for papers, letters, web pages, or something like that? How? To do this, we should talk about document. We say that a document consists of thousands of attributes. Each attribute is a word. But just we are looking for some keywords, not all of words, some keywords. Because Some of words are not interesting for me, but some of them are interesting. Okay, so in each document we have lots of keywords. Then we have to create an occurrence matrix of those keywords and in different documents. Something like this in slide 61. There are different documents and some keywords. I don't know how many, I don't know, but there are some keywords. So again, for each document, I create a matrix something like this. For example, for document 1, I have some keywords. I should count number of those keywords in document 1. For example, in document 1, the word team has been repeated 5 times. There is no word coach in document 1. The word hockey is repeated 3 times. The word baseball is not repeated. The word soccer is repeated 2 times. The word win is repeated 2 times. In document 2, the word team is repeated 3 times. Hockey 2 times. Soccer, penalty, win, and season are repeated only 1 times. And in rest of the cases. In all cases, I have to count number of repeats of each keyword in that document. Then, after creating this matrix, then I have different choices and different options to calculate the similarity between documents. But one of the best and easiest ways, lightweight algorithms, to calculate the similarity between these items is using Cosine similarity. Cosine similarity is calculated in this way. First, we should dot product of two vector d1 and d2 divided by the length of times of length of vector 1 and vector 2. What is vector? Here, each row or each record in this table, in this occurrence table, is a row, is a vector. I can tell them a vector. So here in this example, I have 4 different vectors. So I can use Cosine similarity to define their distances, their similarity. For example, document 1 and document 2 here, I'm writing them in this way, like this. D1 is a vector with 10 different dimensions. Values of these dimensions are 5, 0, 3, 0, 2, 0, 0, 2, 0, 0. D2 is another vector with values 2, 0, 3, 0, 2, 0, 1, 1, 0, 1, 0, 1. These are 2 different vectors. And I'm trying to find their similarity using Cosine similarity. Firstly, I should calculate the dot product of those vectors. So I'm doing that something like this. 5 times in 3. Look at this. 5 times in 3. Values of each attribute times together are time together. 5 times in 3 plus 0 times in 0 plus 3 times in 2 plus 0 times in 0 plus 2 times in 1 plus 0 times in 1 plus 0 times in 0 plus 2 times in 1 plus 0 times in 0 plus 0 times in 1. In this way, I can calculate the dot product of D1 and D2. The total is 25. The dot product of vector D1 and vector D2 is 25. Also, the length of D1 can be calculated using Euclidean distance, as we present it in the past slide. 5 times 5 plus 0 times 0 plus 3 times 3 plus 0 times 0 plus 2 times 2 plus 0 times 0 plus 0 times 0 plus 2 times 0, 2 plus 0 times 0 plus 0 times 0. And then we should calculate the square root of this summation. The final answer is 6.481. We can do this for D2. The result is 4.12. And now, if I replace this value into Cosine similarity formula, I will receive value 0.94. As we talked in the last session on Sunday, similarity is a value between 0 and 1. 0 means that there is no similarity between two objects, and 1 means that two objects are completely similar. Here, I can see that D1 and D2 are similar, not completely similar, but they are near to each other, very close. They are very close to each other. Not completely, but they are very close to each other. This is an effective and easy way to find the distance and similarity between different documents. This is very important. This way is very simple. You can see that most of the calculations are just simple times or summation. Just here, we use a square root. Just we have two square roots, nothing more than this. And then deviation, a division at the final stage. It's very simple, very effective, and a straightforward method to calculate the distance between, or to calculate the similarity between two different documents. A simple search engine can use this. However, a powerful search engine like, for example, Google or Bing or Yahoo or something like that, are using complicated methods, but Maybe one of the most interesting, effective, and simple method for a search engine is Cosine similarity. Okay. Um, in this chapter, we learn about data types of attributes: nominal, binary, ordinal, interval scale, ratio scale, and other types of data set: numerical, text, graph, web, and image. Also, we talked about some basic statistics: mean, central tendency, mode, uh, quantiles, and something like that. Also, we talk about different types of charts and graphs to presentation of data, especially box plots and histograms. And finally, we talk about calculating data similarity. Now, we are standing at the first of data preprocessing step, at the first position of data preprocessing step. As we talked in chapter 1, before entering into data mining techniques, we have to preprocess data. In chapter 2, we learn how we can stand in the first position of data processing. In chapter 3, we learn how to start data preprocessing, how to choose different steps, and how we can apply preprocessing. But now, before of starting preprocessing, we have to learn about data. Someone give me a data, and now I'm learning about data, about that data. What is that data? What about its properties, similarity, and something like that. Inshallah, in the next week, we will start chapter 3, and I will tell you that how we can pre-process a data set. Okay. But before of the next session, in the LMS, I will give you an assignment. I will upload an assignment. I will give you a data set, a link to a data set, and I will ask you to analyze the data set. For example, finding types of attributes, finding its primary statistics, finding similarity or something like that, presenting its data in graphs or different charts or something like that. I will give you this assignment in the LMS very soon. Please do the assignment in 2 weeks. Found the history and dates, interval date of that assignment. Okay, that is enough for today. Is there any question?